Okay, so the final video in this series is about translating English into differential equations, which, whether it's unfortunate or not, doesn't mean that you can translate your English homework into math homework. It'd be pretty amazing. But rather, if we have a sentence that's written in English, can we convert that into the mathematics of differential equations? And there's a couple of pieces of vocabulary that we need here. One of those pieces of vocabulary is knowing what directly proportional and directly proportional and inversely proportional mean. And so I just want to cover those things briefly. If someone says that A is directly proportional to B, so if A is directly proportional to B, what it means is that A is equal to B with some proportionality constant in between. Now that proportionality constant might be 2. If it was 2, it would mean that A is always twice as big as B. If K was 3, it means that A is always 3 times as big as B. If K was a half, it means that A is half as big as B. Directly proportional just means that one of them is some constant times the other one, right? If A is inversely proportional to B, so again, A inversely proportional to B, it doesn't mean that the constant is inverted, because that doesn't matter. I mentioned before, K could be 3, K could be 2, K could be 1/2, K could be any constant, right? Saying that it's inversely proportional is saying that A is equal to 1 over B, again, with some proportionality constant thrown in, right? So the idea here is that as A, in directly proportional, as A goes up, B goes up. In this one, if A gets larger, B effectively has to get smaller in order for this to balance out, right? So really that's the only vocabulary that you're going to need to know in order to work through the rest of these problems. Any other vocabulary we'll pick up along the way. So I've got 4 examples of these, and they're all going to be pretty quick. Note that in the homework tonight, your job is not to solve these differential equations, but simply to write them, right? So the one other piece of vocabulary that I left out was this concept of rate of change, but we've talked about it before. When you see rate of change, you should immediately be thinking of derivative. So when you see that this thing says the rate of change of y with respect to t, like this whole thing should read to you as dy dt. The rate of change of y with respect to t. Then the next thing it says is directly proportional to, right? So what does that mean? It means that it's equal to k times, and what is it directly proportional to? It's directly proportional to the square of t, which means t squared. Congratulations, you've translated English into a differential equation, right? Could we solve this differential equation? Sure, but that's not in the homework tonight. That's not what I'm asking of you right now. And if you really wanted to, do it. I mean, this is now, I no longer even need the sentence in this. I've got a differential equation. I can apply all the math that I know about this to solve that differential equation. Again, not in the homework tonight. You're not going to need to worry about it until tomorrow. On to the next example. For this one, the rate of change of p with respect to t is inversely proportional to the square root of p. If you're watching this at home, I'd really recommend you pause for 30 seconds and try and write this one down. There's not a whole lot of work to be done. It's worth a shot. So the rate of change of p with respect to t, that means dp dt, then is inversely proportional to, that means it's k times 1 over whatever is about to come up. The square root of p, that means the square root of p. Yay, there's our differential equation, right? Now again, I'm not asking you to solve it. You don't have to do that. But I would point out, if we needed to, we would just use that 4-step process. As a review of the previous lesson, I'm going to do that now. If you really don't want to see it, you can fast forward, I suppose. The first step was multiplying the dt over, so you'd have dp equals k times 1 over root p dt. The next step is separating variables. So separating variables just means we need to move the square root of p over. So you'd have the square root of p dp equals k dt. And at that point, it's been separated, right? At that point, you take the antiderivative of both sides. Again, I'm going to stop myself here and not go any further into it. But the idea is we can take this English sentence that we have, I can translate it into a differential equation, and then I can separate and solve. It's good stuff. 2 more examples, and then we're done. So sometimes you're going to have a lot of other words thrown in, and you're going to need to translate into variables. So this one here says the rate of change of a population of butterflies, and we actually go on to say, okay, the population means p, with respect to time, which means t. So again, we're starting off with what we already know. The rate of change means dp dt. That is directly proportional to, so equals k times, and what is it directly proportional to? And this is a little bit interesting. It's directly proportional to the difference between the current population and a constant m. So mathematically, how do we write that? Well, mathematically, the difference means subtraction. Difference between the current population, that's p, and the constant m. Great, so this is times p minus m. Now, this isn't necessary for tonight's homework, but I'm going to throw 15 seconds of instruction in here. What variables are there in this problem? Right? There are really only 2 variables. Right? The variables are p and t. How did I know that? They're the variables that are here. The other letters in the problem, k and m, are both constants. Right? How did I know that? Well, k is a fancy name. It's called the proportionality constant. The k that you use here is always going to be constant. Now the m, we were told that it's a constant m. So tomorrow when we get into actually solving these things, know for a fact that the letters over here, p and t, are the only ones that are actually variables. Any other letters are constants. Last example. It can happen that you have something that is both directly proportional and inversely proportional. And really, you just use one proportionality constant. You just put the things in the right place. So this one, the rate of change of the velocity with respect to time. I'm not using letters this time, but I think we can probably figure it out. For velocity, let's use v. For time, let's use t. Rate of change of velocity with respect to time, that means dv dt is equal to, and if you're watching this at home, we're almost at the end of the video, pause it, see if you can guess what the setup of this is going to be, and then check it. So both of these things require k times, right? Directly proportional to just means that thing is going to be like on top, so the square of time, you'll have t squared here, and inversely proportional means that'll be on the bottom, proportional to the sum of the velocity and the time, so that means v plus t. And there you go. There's your differential equation. I should mention, the first 3 examples we did are all things that we can solve, that you guys have the tools to solve. This last one, we most definitely don't. Certainly not in the first year calculus class. We might in the second year calculus class. I haven't looked at it. I was really just throwing together an example for us. That's the end of this video. That's the end of the 5.6 sequence. So I definitely would recommend that you guys take a look at the homework now. Go through, do problem number 1. That's one of the verify problems. Do problem number 4. That's one of the, actually number 4 is kind of boring. Maybe number 5 is one of the general solution problems. And then, try problem number 11. That's one of the writing equations problems. Do those before class tomorrow, and I think you'll have a good sense of whether or not you understood what happened in the videos. So I look forward to seeing you in class.